Okay. Hi, everyone. Thank you for coming to my talk. My name is Samuel, and I'm a senior software engineer at Bloomberg. I work on IB, which is Bloomberg's messaging application. I'm a full-stack developer, and we code primarily in Python and JavaScript. The title of my talk, if you came to a Python conference, now go to a PR review. I came up with this because I've been to a lot of Python conferences, and I feel like depending on the talk you go to, you might go to talks where you have to do a lot of research after the talk to be able to implement stuff. But I wanted to think about something actionable where if you're here right now, either you or your company, someone has invested a lot of money in you to be here. So I wanted to make sure that I gave a talk where you could kind of listen, not have to do a lot of research on your own, and be able to implement things when you go back to your regular job. And that's what I hope to do with this talk. I focused on PR reviews because I feel like PR reviews are an often overlooked way to make an impact. I think if you're an engineer, you think that you can make an impact by writing a lot of code, doing a lot of design and technical work. But I think PR reviews is a really good way to make a big impact as an engineer. I'm going to go over kind of why I think that's the case. So really quickly, the agenda for the talk, we're going to have a brief introduction. We're going to talk about the archetypes of bad code reviewers. We're going to talk about the technical knowledge that I feel like you should have to do PR reviews in Python effectively. We're going to talk a little bit about communication related to PRs, and then we're going to just end it with a conclusion and a takeaway. So really quickly, why am I focusing on PR reviews? So PR reviews boost code quality and team learning. It's a really good way for you to be able to show other people on your team what you know. One way to do that is by doing PR reviews properly. The other thing is if you're a good senior engineer, you can catch bugs early before they go on to production. A lot of times code that gets merged really quickly without having gone through a good PR cycle can end up crashing on production. And if you're a good, solid senior, you want to be able to catch that before that happens. It's a good way to do mentorship and collaboration, just teamwork. You can't always code with someone, but you can review their code when they're done doing it. It's critical for scaling projects. Like I kind of said before, you can only write so much code as an individual contributor yourself. But if you write code and then you review code for other people, it's just more of an opportunity for you to make an impact at your company. And then, yeah, it scales the contributions that you can make as an individual. So what's unique about Python PR reviews? Why is it different than doing PR reviews in any other language? There's a lot of similarities with the teamwork and collaboration, but there's a lot of things unique to Python that present a unique opportunity to do PR reviews in Python. One is that Python is dynamically typed, which means that you need to increase the context that you have when you're doing these PR reviews, which means you also need to scrutinize deeper. If you have a type language, you can kind of infer the data that's being passed around, but if you're doing PR reviews in Python, you need to be more mindful of that. Python is idiomatic. I think as engineers, we often think about there's many ways to solve a problem, but with Python, it's unique in that there are still many ways to solve a problem, but there are a couple of Python-specific ways to solve problems, and we'll get into that a bit. And then Python has batteries included. I think engineers often go into the habit of making new solutions for things that already exist, but Python has a lot of libraries and a lot of things in its package that you can use that a lot of people just aren't aware about, so we're going to go into a couple of that as well. So what did I mean when I said Python is idiomatic? So on the left, you can see the less Pythonic index loop, and on the right, you can see a more Pythonic using enumerate. They're kind of the same lines of code, but one benefit of writing Python that's idiomatic is that if you have a large code base and you don't do idiomatic Python, let's say you solve a bunch of different problems different ways, that leads to your code base solving the similar problems in very different ways, which makes it hard to maintain. It makes it hard for a new developer to come and understand. But if you solve similar problems in similar ways, it makes it a lot easier for you to be able to understand your code and for newer people to come and be able to contribute quicker. Python has batteries included. So there's the with statement for resource management. There's default dict. There's pathlib. There's a bunch of other things in the Python library that you can use that will help it to be more idiomatic, but also be shorter. And then that's kind of a super high level. But if we go into part one of this, which is the archetypes of bad code reviewers, I wanted to talk about like some of the code reviewers I've experienced, and I think the negative things about PR reviews that tend to be common, and I kind of bucketed them into three different groups I'll go over right now. The three different groups are the looks good to me reviewer, the technical nitpicker, and the nit commenter. So the looks good to me reviewer, they kind of leave vague and unhelpful comments. They don't really engage with the code. They can miss bugs, and then they can miss things that the person making the PR is doing, and then they don't really offer you any direct feedback. I think a lot of times I even get put in a situation where I review someone's code and it more or less it looks correct to me. There's really nothing I can leave a comment on. If I do leave a comment, it might just be nitpicking, which is one of the other archetypes I'll talk about. But I think even if that's the case, if you're reviewing someone's code and there's nothing wrong with it, I think it's a good idea to say, hey, this is what I reviewed. This is what I think your design is. This is why it looks good to me, and then approve it. So even if there's nothing wrong, I think it's still helpful to kind of say what you reviewed so that the person who's making the PR, they might not know that they wrote flawless code and you don't have any issues with it. They might be leaving unclear about what they've actually reviewed. So if you kind of, even if it looks great, even if you just say, this is what I reviewed, this is what I think your code is doing, that's still helpful. The other one is the technical nitpicker. They focus on minor or irrelevant issues like variable naming or like personal styling preferences. They kind of overwhelm the PR with a lot of small but low impact comments. They create work for you to do as, like, if you're someone making the PR, you have a bunch of comments and there's a lot of work you need to do now to make all these updates, but it's kind of unclear why making these updates are going to help and why it's going to make your code better. And it kind of discourages contribution, because if someone is leaving a lot of, let's say you make a PR and you got like 20 little nit comments, it kind of stops you from being able to engage with the person or engage with your code more. And you kind of just end up having to solve all these small problems. You don't really know why you're doing it. And you definitely don't want to be this person. I think the solution here is that you want to make sure that you weight the comments that you give by the impact that they have. If you feel like you have a lot of small comments, but they're not going to make a lot of impact, I would refrain from doing that. But if you feel like you have a lot of comments that can make a lot of impact, kind of leave smaller but more impactful comments and stay away from leaving many less like nitpick comments. And then the third one is the nit commenter. So this is different than the second one, where this person does find bugs and they find things that you probably are doing wrong, but they don't really explain it to you. I think this is probably the most common one, where if you're a junior and you're giving a PR to a senior to review, or if you're a senior and you're reviewing it, it might be really clear to you why something is wrong and you might not understand, or you might just think if you just leave a small comment, they'll be able to figure it out. But I think with PR reviews, you want to use that as an opportunity to communicate and show that you can communicate and show that you can teach. So I think for the solution to this, if I had to give one solution, it's really simple. Just explain why you're saying to do something. So if you think something is inefficient, maybe explain why that's inefficient, and then go into detail about what is a more efficient way of solving the problem that they're trying to solve. But these are kind of the three archetypes of bad code reviewers that I have seen. So if we move on, how do you actually like give feedback? How do you make sure that you're not one of those three people? The first thing is you need to make sure you kind of have like a baseline level of Python knowledge that I have seen by doing PR reviews about the mistakes that people make and how you can kind of make sure that the PR reviews that you do are effective. So if we go into that kind of one by one, the first thing is knowing about Python's model. Python is not passed by reference, it's not passed by value, but it's passed by Python variables reference objects. So what does that mean? Before that, we need to discuss whether or not something is immutable or mutable. So when reviewing Python code, you need to ask yourselves, will the object be mutated, and is this mutation intentional? So to keep in mind, the things that are not mutable are ints, strings, and tuples. The things that are mutable, meaning they can change in your functions, are lift, dicts, and fetch. So if we show an example right here, you can see that I have an add one function that takes in a list of numbers and adds one to each thing. This function is clearly mutating the list that is passed in. But if you're reviewing code, you kind of don't know if this mutation is intentional or not. You have to like ask the person making the PR. You have to look at other context. You need to figure it out. But you won't even know to do that if you don't know about Python's object model. So another thing is default mutable args. On the left, you can see that we have an append method that has a default list being passed in where it's an empty list. On the right, we have the same append method, but it's taking in none instead of the default one. And if I go on to the next slide, you want to be using the one on the right and not the one on the left. The one on the left is maintaining state because, again, lists, like we said, are mutable. So since they can change if you pass them around in functions, if you call append once and you pass something in, when you call it with another number, it'll keep that state. But on the right, where you pass in none instead of an empty list, you're not getting that state management issue. And again, I'm not saying, in this image, I'm clearly saying one is bad and one is good. But I think the more important takeaway is that you want to make sure you understand why someone is using an empty list or why someone is using none. But if you don't know the distinction, then you're not able to make that comment in a PR. So that's one thing to keep in mind. Default mutable args, there's a lot of potential bugs that can come with it. So there's shared state across function calls. The default list is created once, so subsequent calls modify that same list. There's non-obvious behavior in loops and tests. It's especially harmful if you're doing test code or APIs where the user assumes that there's some fresh state. If you're passing in the same list, then that won't happen. And it's also hard to track side effects. Reviewers might not notice state being preserved unintentionally, so you just need to be really mindful of that. And again, so if you're dealing with default mutable args in code that you're reviewing, you just need to check whether or not they're using lists, dicts, or sets. And if you see something, you just need to ask yourself, should this be a fresh variable every time, or should this be not fresh? And then many Python developers, using experienced ones, don't know how to look at this effectively, so this is something that I wanted to call out. Now if we move on to efficient and idiomatic Python, this is where a lot of opportunities come in as well. So Python offers elegant and concise idioms that reviewers should encourage. This basically means don't solve problems that were already solved for you. Kind of do things the Pythonic way so that if someone is looking at the code later on, it follows kind of a similar pattern. One example of that is loops versus list comprehensions. So on the left, we have a verbose loop, and on the right, we have a less verbose list comprehension. This is kind of a very simple example, but you could already see that the code on the right is much shorter. And shorter code is fewer lines, and fewer lines means there's less context for you to maintain, less bugs that can go into production. The one on the right expresses intent more clearly. It's very clear what you're trying to do. And it's also often faster because different compilers optimize bytecode differently. So if you have the code on the right, it'll often run faster in production environments as well. There's also map and filter versus comprehension. So on the left, we have a filter. On the right, we have a comprehension. It's easier to read for more Python developers. It avoids the anonymous lambda function we have on the left. And again, it's just more Pythonic and more idiomatic. And then we're going to go into generator for a little bit. So generators provide lazy evaluation. They're memory efficient for large data sets. They're composable built-in tools like iter-tools. And they're great use cases for streaming data like APIs and logs. So you can see on the left, we have a list comprehension. On the right, we have a generator. Again, this is just one line of code, so it doesn't really change the complexity too much, but it's more Pythonic and modern code bases, which means that over time, if you're managing a really large code base, if you're using generators, it just makes it easier for people that are interacting with your code base to understand it eventually. So for generators, there's kind of a few things you need to ask yourself when you're reviewing code. Could this for loop be replaced by a generator? And then do you have a list or another large collection? And could a generator help you save memory with that? And ultimately, you just want to ask yourself, is there a more expressive way to do the thing that I'm trying to do? And often you'll see that generators help you do that. And then the next thing that we'll move on to is underutilized tools in the Python standard library. Like I said in the beginning, Python comes with batteries included, but many devs don't use them. And as a reviewer, you want to spot manual code that could be replaced with standard tools that make for high impact in your code, but also make high impact comments for you as a reviewer. And you want to emphasize that Python provides a lot of elegant built-in ways to solve common problems. So one example of that is using pathlib over ospath. On the left, we're using ospath, but on the right, we're using pathlib. It's cleaner syntax with the / operator. Pathlib also have more powerful methods like retext, exist, and glob, and it's better for cross-platform safety as well. With ospath, it might not work the same way on different platforms, but with pathlib, it's abstracting away a lot of the low-level OS stuff for you, so you just don't need to worry about that. Another thing that you can use is default dict that most people don't use in code. On the left, you can see that someone is using an empty dictionary, and they need to do a check every time to see whether or not something is in that dict. But on the right, they're using default dict, which kind of takes away that little bit of boilerplate they're using because they're using a real dict. So in this example, using a default dict, it removes boilerplate, it encourages safer, shorter logic, and it can also be used for grouping. Like you can do default dict and you could pass in a list. So if you're reviewing code and you see someone is using if key not in dict, that's often a good indicator that they can use a default dict to solve that problem. Another thing that's really helpful is type annotations. On the right, you can see that we're using type annotations to show what type this function gets in and what it also outputs. This just makes code easier to understand and maintain. It enables static analysis like MyPy and Pyrite, encourages clean APIs and phase refactoring. This is something that I really like using, and I found that most people don't use. But again, if you're doing a PR review, you want to make sure that you leave high impact comments, but not high impact comments just for the sake of like leaving comments, but you want to make the code base ultimately better to maintain and use long term. And type annotations in Python are not used that regularly, but they help a lot. Another thing is using data class. Just like with default dict, it removes a lot of boilerplate. If you're using data class, you might think you can just make a class, but if you make a class, you have to put in a lot of boilerplate, like you have to do an init method, a wrapper method, and a bunch of other stuff. But if you're using a data class, let's say you have a class that shouldn't have any methods, it's just an object that's going to hold data, you can use a data class for that, and that provides kind of a much cleaner way for you to be able to just have an object that should only contain data. And to the reader or to other people that eventually interact with your code base, it'll signal that this class is meant to hold data and not manage behavior. So that was kind of the extent of the technical thing that I want to go into. And now we'll kind of finish it off with the communication related to all of that knowledge. When you're doing code reviews, you want to kind of keep 4 simple principles in mind. It's clarity, respect, specificity, and then you want to explain why. So if we go into the first one, clarity, you want to say what you mean, you want to be concrete. I think if you're doing a PR review, a lot of people might fall into the thing where, oh, if I just say this one quick sentence, they'll know what I mean. But especially if they're a new developer, or even if they're a senior developer, they might be working on multiple projects, multiple PRs at the same time, across multiple languages. It might not always be clear what you mean. So I think if you just say what you mean really simply, really concretely, it makes it easier to take PR review feedback. The other thing is respect. I think rarely, but on some occasions, I have definitely seen where people kind of assume bad intentions when they look at a PR. But what I like to do myself is when I'm doing a PR review, I kind of always assume good intentions. I assume that someone wanted to do things the right way. And if they didn't do it the right way, they either didn't know or there's some other thing that came up. So I kind of always try to be respectful. And you always want to make sure you critique the code, not the person. PR reviews can end up being kind of a little heated and personable if they get into that. But if you just focus on the code and the technical things that you're reviewing, less so on the person that you're reviewing, that makes that process a lot smoother. And then the third one is specificity. You want to point to specific lines in code. You don't just want to say, this PR looks bad or this PR looks good. If something looks bad, you can point to a specific line and say, hey, I think this looks bad for reasons ABC. Or if something looks good, you can say, I think this looks good for reason ABC. But you want to make sure that you're specific on why something is good or bad. And then you want to actually describe the issue. You don't want to call something out and say, this is bad. You can be like, this is inefficient because this loop is doing this, but it should be doing this. And that's kind of what I mean by be specific. And the last one is explain why. This is kind of baked into all of the other stuff that I'm talking about. But you don't want to just say what to change, but you want to say why the change that you're suggesting is an improvement. Because if someone doesn't really know why something is better than whatever they were doing, it kind of makes them less reluctant to do so. I definitely feel that way. I feel like when I get feedback comments, it's important for me to learn why something that someone is suggesting is better or why something is different, like a better way. And you want to make sure you convey that and explain why. So takeaway for Python PR reviews, Python is expresses. There's Pythonic code versus working code. I think engineers often fall into the problem of there are many ways to solve this, so kind of anything can work. But with Python, especially for really large code bases, you want to solve the same problems the same way. That makes it a lot easier for people to maintain long term, and you want to do it in a Pythonic way. You want to balance correctness with timeliness. You want to make sure you don't overwhelm a PR with a bunch of small nitpick comments. You want to make sure that you leave kind of high impact comments. So you want to focus on the most important things. And then if you're a senior and you're doing a lot of PR reviews, you want to use your experience to mentor and scale your impact. There's only so much code you can write as an IC yourself. But if you're reviewing other people's code, that's kind of a part of the work that you did that goes on into production. And ultimately, that's just what you want. And that is it. Thank you.